connectivity for the industrial space. If you look at this space for connectivity in the factories, you got the IT. The IT is the normal Ethernet infrastructure that you have in the factory. And over there, there's a very, very clear solution for connectivity, which is the Ethernet. Everybody's using it, cabled Ethernet. But when it comes to wireless connectivity, for the wired connectivity for the machines, for the OT, for the operation technology, there's a variety of solutions. Actually, it's a very dense market with many manufacturers giving their own type of technology and solution for connectivity, such as the Profinet, the EtherCAT, the Modbus, Ethernet IP, CC-Link. But when it comes to wireless, there are many challenges in the factories. And for the IT, it's easy. We're using Wi-Fi for connecting for the non-mission critical, time critical. Some Bluetooth, sometimes Zigbee is also entering this when it comes to industrial IoT. But when it comes to the OT level, there's no solution currently, or there hasn't been until now, because there are many challenges in connecting something in real time that has to be reliable enough. And what we're offering is the Iot Wireless. It's I will explain about this a little bit later, but Iot Wireless is a technology, it's a relatively new technology that offers very deterministic connectivity for the design specifically for the harsh environments of the factory floor. It has very low latency, very high reliability, and it's scalable to fit for the entire industrial floor. And Coretigo is one of the earliest adopters of this technology, actually one of the founding members of this spec. And we offer a full solution for this. Now, if you look at why do you even need wireless communication in the factory for machines, I'm not talking about connecting laptops or IT level devices, but for the machines, for the actual sensors and devices, sensors and actuators, for the actual devices. Well, the obvious solution is that cables are limiting. Cables don't let you have enough flexibility and agility. You want to add on new devices. Sometimes you want to move machines. Some cables are very complex, like in drag machines, there's a wear and tear where cabling can get damaged. And all these are very appealing environments for replacing cables with wireless. But there's another category where cabling simply isn't possible. When it comes to devices that are on the move or devices that are rotating, it's almost impossible it's virtually impossible to connect any cable. So let's say that you have a system that is running on the head of the CNC machine. The head of the CNC is rotating at thousands of RPMs, rotations per minute. And obviously, you cannot put any cable connecting to the actual rotating part. You can have sensors and actuators in other parts of the system, but not there. And for all these solutions, we have the Iot Wireless Technology. I'll give you a second to read the Chinese. Okay, so Iot Wireless is a standard. It's a global standard. I'm pretty sure a lot of you are familiar with the Iot, which is the way to normalize and digitize connectivity to sensors and to actuators in the factory. Iot Wireless is an extension of this technology, and it is a wireless technology designed for factory automation. It's universal, which means it's vendor agnostic because it's a standard. It has a very deterministic 5 millisecond latency, which is virtually no latency at all. It is very reliable. When I say it's reliable, what I mean is it's 1 million, and I don't mean it as a figure of speech. It's literally 10 to the minus 6 better than the existing wireless technologies. So such as Wi-Fi or BLE or Zigbee. we offer 10 to the minus 9 packet error rate ratio, which is just as good as cable. It's scalable, so you can have hundreds of devices, of wireless devices, on every machine or in every area of the factory, even more. And it's deterministic, which means that we guarantee that the packet arrives in a very, very specific time and very specific delay. So where do you use it in the factory? There are many areas where it's usable. The first one is in sterile environments. Sterile environments is where cables are a big obstacle because everything that is a sterile environment, food and drugs, or hazardous materials, has to be cleaned constantly. When you have less components, less cables, less connectivity, it's much easier to maintain. And also, it's currently being deployed, for example, on robots that are cleaning tanks in the hazardous environment areas, where, again, cables is typically not possible because they're on the move and they're constantly moving. You cannot connect a cable to them, long enough cable. Retrofit and condition monitoring, meaning that, let's say you have already a machine, you want to add on additional sensors. Now, with the amount of sensors that are already there and the amount of cabling that is already there, it's almost impossible. It's way more than nice to have. And sometimes the production lines today need changing, constant changing and moving. So you want to move a machine elsewhere. Now you have to take care of all the cabling and sensors that are connected to it, connecting it to the PLC, etc. Robots and cobots, those arms that are constantly moving, when you want to add an end of arm device to a robot and a cobot, you have to do it externally. Now, the main thing about robots, robotic arms and cobots, is that they have to be flexible. Their motion is the most important thing about them. Now, when you add cables to them, then you get into a lot of troubles. First of all, it limits the motion. Second, and the flexibility. The second thing is that if you add cabling, then you are running into cable wear and tear because they're constantly moving. They're stretching the cable, they're wrapping it around, and you get a lot of malfunctions. Adding wireless devices, and we're already working and showcasing with a bunch of device manufacturers and robotic arm manufacturers and cobots, adds a lot of flexibility, much less cost of deployment, and makes them universal. So you can add, in one production line, you can add a pump, and the other one, you can add a gripper, and you can interchange between them with no real problems or times or delays or engineering efforts. Intelligent tooling, we just showcased along with Rome, which is the main OEM provider for these tools, we just showcased a smart gripper. The smart gripper sits on the end that is actually rotating and lets you measure the force of in which the material is being held in. So it prevents manufacturing technicians' skills dependency. So you don't depend on the skill and how strong they think they should attach the material. So in this case, it lets you do during the assembly, during the connection of the materials. It lets you measure the actual strength. And then during production, it monitors, it keeps on monitoring how strong the material is being held. That gives you a lot of flexibility, a lot of data that you couldn't get from the machine before, because this was the black zone of the machine. You couldn't get any data from it. Rotary tables keep rotating. These are the carousels that keeps rotating in the factory. Until now, you couldn't put any sensors on them, or you were very limited in the amount of sensors that you could put on them because you were dependent on O-rings. Now, with wireless technology by Coretigo, with our Link Wireless, you can put multiple devices, you can get real time with low latency, and you stop the packet error reliability issue that you had with the O-rings. So on rotary tables and carousels. But the main place where it's currently being deployed, and we won a bunch of projects with Klustermans, for example, which is a machine builder building machines for AB InBev, biggest manufacturer of beverages. In their packaging machines is the transport tracks. The transport tracks is the independent devices, the shuttles that are going across what used to be in the past conveyor belt. Now you want to do parallel processing. You're no longer depending on each on the line of the conveyor belt. Now each device is independently moving, but the problem is because it's independently moving, it's a magnetic device that can get wireless power, but couldn't get wireless connectivity until now. So let's say you're manufacturing ice cream and you want to measure the weight, the actual weight of the ice cream, and not just the time that the valve is being opened in real time. So you can stop it and you can adjust it. Now you can put a weight sensor on top of the moving platform, which you couldn't do before. So this, in a nutshell, is the solutions that we have in the factory. There are a lot more solutions and a lot more manufacturers that are already using our technology. As far as the solution that we're offering, you got the Iot Wireless Devices connectivity. That's the part that you connect to the Iot. So if you have an Iot sensor, we offer the bridge, the Tigo bridge. The Tigo bridge connects directly to the output of the Iot, to the same connector as where you used to connect the cable. You don't have to do any engineering. It's an easy win, and it makes every cable into a wireless. Any Iot cable that you had before, you can now connect the wireless device, the wireless Tigo bridge to it, and making it wireless. So this is something you can do directly on devices, on the actuator and sensors, but you can also connect it to a hub, by which case you can connect non-Iot sensors and devices to it, analog or digital. You have the Tigo Air Sum, which is being used by manufacturers to integrate. This is in the process of design of machines and sensors and actuators. You can actually integrate wireless technology directly into the device, not as an add-on. And on the other end, on the master side, you have the Tigo Master. The Tigo Master is what receives the wireless transmission and converts it into industrial Ethernet for the PLC. We have a bunch of protocols that we are supporting already, and also making it into an IoT protocol such as MQTT or OPC UA, where we can send it directly to the cloud or to our Tigo engine. Our Tigo engine is the setup environment and the monitoring environment that we're offering as a software on the software side that lets you configure the system, whether wireless, which devices, IODD, things like that, but also collect the data, add on automation, and a bunch of advanced functionality, and send data to the cloud for integration with other systems or with the dashboarding or big data collection. This is what we do. Feel free to contact us later on if you need more information or if you have any other further questions.